Hey, how's it going? So we'll be covering characteristics of quadratic functions. So when it comes to quadratic functions, let's go ahead and look at four major characteristics of a quadratic function. You have a vertex, we'll start with there, because that's probably the most important aspect of a quadratic function. That's where the change in direction. So if it's facing up like it is here, the vertex is going to be the lowest point, all right? And if they ask you for the minimum, that will be the y value of the vertex. And then if it's facing downward, then the vertex would be your highest point, which they ask you for the maximum, that'll be the y value of the vertex. So the axis of symmetry also cuts through the vertex. That's a line, an imaginary line, that's going to split your graph in half, or split your function in half. All right, so as long as your quadratic function is facing up or down, the x value of the vertex, x equals whatever that x value is, that is going to be your axis of symmetry. It's going to be cutting directly through the vertex every time. The other characteristic is your y-intercept. It's wherever your function crosses the y-axis, as you can see here. And the other characteristic is going to be your x-intercepts, wherever your function crosses the x-axis. Hence, intercept the x-axis. But remember, x-intercepts can also be your solutions. It also can be your roots. It also can be your zeros. Those are all different ways of saying x-intercept. So now, depending on what form your quadratic function is written in, certain characteristics are being exposed to you without even having to type in the graph. What do I mean by that? If I give it to you written in standard form, the constant, which is the number with no variable associated with it, that constant is my y-intercept. So if I look at my constant of 5 here, that's my y-intercept, which is 0, 5. If it's in vertex form, you should be able to state what your vertex is without graphing it. It's the opposite sign of what you see in parentheses. So -6 is my x value, -5 is my y value. That's my vertex. And then my factored form, you should be able to find your x-intercepts, your roots, your solutions, all from this factored form. Because you would take each factor, you would set it equal to 0 and solve. So x plus 3, set it equal to 0. Subtract 3 on both sides, you get x equals -3. Hence, that's where it crosses. Take x minus 5, set it equal to 0. Add 5 to both sides, you get x equals 5. Hence, that's another place where it crosses. All right? So depending on what form, factored form, you should know your root, solutions, zeros, and x-intercepts. Vertex form, you should be able to tell me what your vertex is. And standard form, you should be able to tell me what the y-intercept is without having to graph these. But we are preparing for the end of course test, which you will have a graphing calculator for, so let's discuss the other characteristics. So if I'm given the standard form equation, let's start with your vertex. So if you type in the decimals, you should be able to find your vertex. Vertex, as you see graphed over here, is going to be -1, 8. Because it's facing down, we know that that 8 is going to be our maximum. All right, but we'll cross that bridge in a few seconds. So let's first look at our axis of symmetry, or line of symmetry. It's what splits the graph in half. And as long as your quadratic function is facing up or down, the x value of your vertex is going to be your axis of symmetry. So x equals whatever the x value of the vertex is. So x equals -1 is this orange line here. Now when it comes to facing up or down, we graphed it so you can see that it's facing down. But you should be able to tell me that based off of the equation as well. If this leading coefficient is negative, it's facing down. If that leading coefficient is positive, like if that was just a positive 3x squared, then all of a sudden the graph would face up. All right, so just off of looking there, we should know it's facing down. If it's facing down, that means it's going to have a maximum, which is going to be the y value of your vertex. If that was negative was a positive, it would be facing up. That means the y value of the vertex would now be your minimum. But for this particular problem, the y value of your vertex is your maximum. Now our x-intercepts is wherever it crosses the x-axis. But a lot of times they're going to say, what are your roots, your solutions, your zeros? They're all the same thing. Just see where it crosses the x-axis and click on those points, and you should be able to get that value. Now your domain is how far left and right the graph goes. When quadratic functions are in context, your domain won't be -infinity to +infinity. It'll have limitations to it. But when it's just a function in itself, without a context with it, our domain will be from -infinity to +infinity. That just means it goes to the left forever and to the right forever. Your range is how high and low the graph goes. So if it's facing down, it goes down to forever. So it's a -infinity. But then it goes all the way up to your maximum of 8. So when you do your range, think about if you have a max or min. If you have a max, put the 8 on the back end because that's your largest point, and you know that has to be -infinity. If it was facing up and you had a minimum, put that value over here on the left, and you know it has to go up to forever, so you will put a positive infinity on the right. But we'll see an example of that in a few minutes. Now for increasing. If you look at this graph, you read it from left to right like a book. So from left to right, this graph is going up. So my graph is going up from negative infinity to a -1. You're solely looking at the x values when you're looking at increase or decrease. They're saying for what interval of x values is your function increasing? That's from negative infinity to -1. And then it starts to decrease after you get to -1, your function starts to decrease. So from -1 to positive infinity is decreasing. And as a reminder of function notation, if there's a number inside the parentheses like it is here, that's saying when your x value is -2, go to x value is -2, your y value is a +5. That's what that means. When your x value is -2, your y value is a +5. All right, so let's go ahead and look at our next example. So we know our vertex because it's in vertex form. Now the line of symmetry, it cuts through our vertex. So it'll be the x value of the vertex, x equals -6. Now when it comes to up or down, we know it's going up because look at that number out front. That number out front is positive. All right, so it's going to be going up. But once again, you have the graphing calculator on your end of course test, so just type it in so you can see. When it comes to your min or max, because it's facing up, you have a minimum, and the minimum is going to be the y value of your vertex, which is -5 here. Now your x-intercepts, you just click where it crosses the x-axis. Now your y-intercept, zoom out until you can see where it crosses the y-axis. As you can see here, it crosses at 7. Now for domain, as long as it's going to be just a regular quadratic function with no context, it's always going to be from negative infinity to positive infinity because it goes from left to right for forever. Now the range, think about it. Do you have a max or min here? You have a minimum of -5. So when you do your range, put -5 in that left side and then you go to positive infinity. If you had maximum, you'll put the maximum over here and then put negative infinity over here. Now for increasing and decreasing. From left to right, you read it like a book, your graph is decreasing from negative infinity all the way to a -6. It's decreasing. While it's increasing from -6 all the way to a positive infinity. You're solely looking at the x values when you talk about increase and decrease. So this is my interval of increase and decrease here. Now when it comes to g of -3, -3 is my x value. So go to -3 on the x-axis and see where does your function intersect. It's at -2. That's the y value. So now let's look at our next example, given in factored form. We know our root solutions, zeros, and x-intercepts because we know that given the factored form. But now after we type it into Desmos and we get our graph, we can go ahead and click on this button at the bottom, and then we can see what our vertex is, which is 1, -16. And we know our line of symmetry cuts through our vertex, and it's the x value of the vertex as long as your function is facing up or down. So it'd be x equals a +1. Now we know it's facing up because we can see that our graph is opening up. Now let's go ahead and look at the max or min. If your graph is facing up, your minimum is going to be your y value of your vertex. If your graph is facing down, the maximum would then be the y value of the vertex, but because it's facing up here, our minimum would be the y value of the vertex, which is -16. The y-intercept is where it crosses the y-axis, which is be 0, -15, which is right here. And the domain is negative infinity to positive infinity, because as long as it's not in context, it's going to be from negative infinity to positive infinity until you have limitations on it. All right, but in algebra 1, we won't have any limitations in regards to our quadratic function unless it is in context. We will cross that bridge later. So then when it comes to the range is how high and low your graph goes. So then it goes up to forever. So we know the right side is going to go to infinity. It's going up to forever. And then the lowest part is going to be your minimum, which is -16. So your range is from -16 to positive infinity because you're looking at your y values here for the range. All right. Now when it comes to increasing and decreasing, you're looking at the x values. All right. So as you go from left to right, the graph is decreasing. So it's decreasing from negative infinity all the way to 1. It's decreasing there. And then from 1, as you go positively, it increases again. So it increases from 1 to a positive infinity. Remember, increasing and decreasing is associating with your x values. All right, it says what part of your domain is increasing and what part of your domain is decreasing. And then now for P of 4, that's 4 is my x value. So when my x value is 4, what is my y value? It is -7.